Hi everyone, let's continue on with Chapter 9, Section 5, Other Applications of Compounding. So in the last video I did mention about the GICs, strip bonds, and promissory notes that are common types of compound interest investments that Canadians own. We can apply what we've learned so far to these investments and to the idea of inflation. So again, there's different options that you can have with a GIC. You can see a variable rate, you can see a fixed rate. These probably sound a little bit familiar. We talked about them earlier in this chapter. There's regular interest, and then there's compound interest. And if you remember, compound interest is what happens after a year. Okay, so the investment needs to be more than a year before you start talking about compounding the interest. Okay. So for example here, you're used to this formula. We can use the future value formula to find the maturity value of compound interest. So if the GIC, for example, has a present value of 1, we could figure out what the future value is by taking the present value, multiplying that by the 1 plus the interest rate, which is your periodic interest rate. And remember to do the brackets and the exponents first. If it's a variable rate and it changes throughout the investment, then what you can do is just multiply them out. So instead of 1 plus the periodic interest rate to the power of n, you would take each individual. So 1 plus I, so that would be your first periodic interest rate, and then your second periodic interest rate, and third periodic interest rate, on and on and on until you have all of them up to n. Whereas the original one here, I plus 1 plus I to the power of n, that assumes that I stays the same throughout the entire investment. Okay, so the Chartered Banks offers a 5-year escalator guaranteed investment certificate, or GIC. In successive years, it earns annual interest rates of 1.2, 1.5, 2, 2.5, and 4.3. So you can see right there that we're going to have to use this second method by multiplying it by each of the individual rates. And compound at the end of each year. So compounding periods per year is 1. The bank also offers a regular 5-year GIC paying a fixed rate of 2.3% compounded annually. So that one you can use using this formula, or use the functions, or try both. Do it manually and then try the functions for the financial calculator. Okay, so let's give it a try. So you multiply that out to your future value. Okay, so we took each of the interest rates, 1.012, 1.015, 1.02, and on, to give us the future value of 11/20/10. And then when it's a regular GIC, it's 1.023 because it's 2.3% compounded annually to the power of 5. And then that actually gives you a little bit more. It's 11.20 and 41 cents because up here the rates are different, and down here it's all the same at the 2.3. Okay. So strip bond. A strip bond is a special type of bond where the investor receives a single lump sum payment on the bond's maturity date. Okay. So you know that once this bond matures, you're going to get a set lump sum. So the question is, well, we know what the future value is. We want to figure out what the present value is. How much do we have to pay to get this strip bond that's going to give us a certain amount in the future? The lump sum is also known as the face value of the bond. So the amount that you're going to get at maturity is the face value on the bond. To determine what the investor would pay for a strip bond at some point before maturity, we can discount the face value. Okay, so again, time value of money. Discounting means that if I'm going to be given a certain amount in the future, I'm going to pay less than that now because of the potential interest. Okay, so a $10,000 face value strip bond, so that's your future value, has a 15.5 years remaining until maturity. So there's your number of years. If the prevailing market rate of return is 3.5%, so that is your annual or your nominal interest rate, compounded semi-annually, so twice per year, so there's your M. And in order to figure out your N, we've got 15.5 multiplied by 2, so your N is 31. What is the fair market value of the strip bond? So again, we've got a future value of 10,000. N is 31. Your I, your periodic interest rate, or your is your 1.75. Your J is the 3.5, and the compounding periods is your 2. So remember, you can put this in your calculator as well. So we know what the N is. We'd put in 31N. We know what our IY is, because remember, IY on your financial calculator is the same as your J, which is your 3.5. We don't know the present value, so we'd skip over that for now. We put in 0 payment, and we know that our future value is 10,000, so we put 10,000 future payment. And then remember, you'd need to go second, IY, and then change your PY to 2, because that's the number of compounding per year. And then you'd need to second quit to come back to the main level of your calculator. And then you'd want to go compute PY. And then that is going to give you your present value. And you can do it manually through a mathematical calculation like they're doing here on the screen. Okay. Remember, when we're putting it in a formula, we need, where we want our PY, it's going to be to a negative exponent. So the present value is $5,840.27. And check it in your calculator after trying it and make sure that it's the same amount. So a fair market value of the bond, if we were to buy it today and it matures in 15.5 years with a 3.5% compound semi-annually. Okay. So promissory note is an interest-bearing obligation, much like an IOU. For notes that are longer than 1 year, compound interest is used. Okay. Sometimes the payee will sell the note before it's due, and they'll sell it to a third party. So the 2 steps are find the original maturity value and then discount that back to the sale date to find the selling price. Okay, so a 5-year promissory note with a face value of $3,500. Okay, so that's at 0. Face value, bearing interest of 11% compounded semi-annually, was sold 21 months after its issue date to yield the buyer 10% compounded quarterly. What amount was paid for the note? Okay. So the first part we need to do is fill in the timeline. So we know that the promissory note was granted at day 0. Okay. In 5 years' time, that's when it's going to mature. We know that the interest on the loan, on the promissory note, is 11%, or if we want to figure that out as periodic, it's 5.5, and we know that it's 5 years, and if it's compounded semi-annually, then we know that our N is 10. Okay, so we're going to figure out what the maturity value is at the end of 5 years, and then we're going to take that maturity as the future value, and then we're going to bring it back to year 1 3/4 to find out what is a good price to pay for it today. Okay, so again, it started at day 0 for $3,500. That's how much the promissory note was. So we need to figure out here, a year and 3/4 later, what should I pay for it? So if I wanted to buy this, if somebody wanted to sell it to me, how much would I be willing to pay for it? Okay. Okay. So the future value with a present value of $3,500, N of 10, periodic interest rate of 5.5, the future value of that promissory note is $5,978.51. So that's the amount we put at year 5. Okay. So then if I want to discount that back to find out what the present value of it is today, we're going to take the future value. We're going to figure out what our N is, and it's compounded quarterly, right? So it was sold 21 months after its issue date to yield the buyer 10% compounded quarterly. So that's your new rates. So we're going to do 4, which is your compounded quarterly, and it's going to be 3.25 years because we're already at the 1 3/4 year mark. Okay, so there's 3 1/4 years to discount it back. So that means your N is going to be 13. The new rate is 10% divided by 4, gives you a periodic interest rate of 2.5%. Okay. So if we calculate that out, it's going to give us a present value today of $4,336.93. So if someone were to offer to sell it to us today, that's how much it would be worth us buying it for. And then in the future, we would get the $59.78.51. Inflation. A useful application of compound interest is determining the effect of inflation. Okay, by compounding inflation rates over a number of years, we can calculate prices at the end of the period. So, if the rate of inflation for the next 20 years is 2.5 per year, what annual income, rounded to the nearest 100, will be needed 20 years from now to have the same purchasing power as 50,000 annual income today? Okay. Whoops. So that would mean, so we want to figure out, okay, so if we know that inflation is going to be 2.5 per year over the next 20 years, how much do I need to be making in 20 years' time on an annual basis to be the equivalent of me making 50,000 now? So when you're planning your career, you want to look at that so that your inflation is being built in. So give this one a try and see if you can come up with the fact that in 20 years' time, $81,930.82 is the equivalent of $50,000 today. Thanks, everyone. Hope this helps.